Welcome to Thuma Mina Teaching. This is your first lesson of Quarter 2 Grade 9 Maths, and we will be doing the properties of triangles. My name is Esmery, and this is my Thuma Mina Teaching. Make sure you have a pen, a book, and a calculator in your hand so that you can make notes as we go along. Now let's start by looking at the interior angles of a triangle. If I draw a triangle, I see that these three angles are my interior angles. And I know that if I call them, let's say A, B, and C, that angle A and angle B and angle C together has to give me 180 degrees. That is one of my theorems. But I always need to give a reason for any statement that I make. And that reason I always write on the right-hand side of my statement. So if I say these three angles added together has to give 180 degrees, I need to say why I say that. And my reason would be interior angles of a triangle. Let's do our first example to demonstrate this. Over here I have a triangle and they ask me to calculate with reasons the size of the unknown angle. My unknown angle is angle X. I know that these three angles together, added up, has to give me 180 degrees. So I can write 82 degrees plus 55 degrees plus X is equal to 180 degrees. But now I need to say why I am saying this adds up to 180 degrees. And that is when I write my reason on the right-hand side and I say interior angles of a triangle. It is okay for me to write angles like this. This will also be marked correct in tests. So now I need to calculate X. I can say that X is 180 degrees minus 82 degrees minus 55 degrees. And that gives me a total for X of 43 degrees. Let's do another example with the same theorem. Calculate with reasons the size of X. But now I see that all three of my angles actually has an X in them. So I have unknowns in all of my angles. Now I know that all three of these angles has to add up to 180 degrees. I have a theorem for that. So I can say I know that 3x plus 20 degrees, that is my one angle, plus my second angle, which is 2x, plus my third angle, which is X, has to equal 180 degrees. How do I know that? Remember, I write my reason on the right-hand side and I say interior angles of a triangle. I am also allowed to draw a little triangle instead of spelling out triangle in my reasons. So now I need to calculate X. 3x plus 2x is 5x. Plus another x is 6x. That gives me 180 and I take the 20 to the other side and that becomes minus 20 degrees. So 6x is equal to 160 degrees. Then you will see that if I say 160 divided by 6, I find my answer as 26.6666 never ending. But they will always ask me to calculate it up to 2 decimals. So I actually want it to end over there. So I round off and I see that that 6 will make that 6 a 7. So I end up with my answer as 26.67 degrees for X. Now let's have a look at our exterior angle. It is very important for you to note that an exterior angle is an extension of any side. It has to be an extension. So if I have a triangle and I extend one side of my triangle, I create an exterior angle. Over here I will have an exterior angle now. Also, if I lengthen this side of the triangle, I create another exterior angle over there. Also, if I lengthen this side, I have another exterior angle. Now, for now, I have 3 exterior angles, but I can also lengthen the other sides. Over here, I have lengthened only my one side. But what if I don't lengthen this side? What if I lengthen the other side? Then I create an exterior angle over there. At the next part, what if I don't extend this side, but I extend this side? Then I have an exterior angle over here. Thirdly, my last one, what if I extend this side instead of this side? Then I create an exterior angle over there. So I have a lot of possibilities for exterior angles. What is important for you to note is that I extended any side of the triangle. Now let me show you what I mean when I say that it has to be an extension of a side. If, for instance, I have a triangle and I don't have an extension, it looks like this. That means this one side would have been extended there, but it's not. And this side would have been extended there, but it's not. So that means this extra line that I drew here does not create an exterior angle. This is not an exterior angle. Why not? Because this is not a lengthening of any of my two sides. Therefore, I cannot use this angle here as an exterior angle. Now let's look at our definition of an exterior angle. An exterior angle is the sum of the opposite interior angles. Now, the sum of means addition. I have to add the two angles together. Opposite interior angles are the angles not including the one next to my exterior angle. So if I look at this exterior angle, I can say it is an exterior angle because I see that one side of my triangle is lengthened, it is extended to create this exterior angle. Now, this exterior angle is equal to the sum of the two opposite interior angles. My two opposite angles are the green one and the blue one. It never includes the one directly next to my exterior angle. So that means I know that my red angle is equal to my blue angle plus my green angle. And I can see that if I add 80 degrees plus 50 degrees, I can see that it gives 130 degrees. Now, I always need to give a reason, remember, for making any statement. And my reason will be exterior angle of a triangle. Now let's do an example using this particular theorem. I can see that in my triangle, I have one side extended. So that means this red angle that I'm drawing here is an exterior angle. I know that the definition for an exterior angle is that it is the sum of the two opposite interior angles. It never includes the angle directly next to my exterior angle. So that means that I know x would be equal to 75 degrees plus 36 degrees. But how do I know that x would be equal to those two? That is because I know my theorem, so I need to write a reason. And my reason is exterior angle of a triangle. So I write on the right-hand side of my statement, exterior angle of a triangle. Now I need to calculate x, and if I add those two angles up, I find x equal to 111 degrees. Let's do another example. Once again, calculate with reasons the size of the unknown angle. That is x. But x now is an interior angle. And I see that I have an exterior angle, this 100 degrees, because my side of my triangle is extended. Therefore, I know that my exterior angle will be equal to the sum of my two opposite interior angles. X plus 30 degrees, my two interior angles on the opposite side, will be equal to my exterior angle, which is 100 degrees. How do I know that? I need to give my reason, and my reason is exterior angle of a triangle. Now I need to calculate x, so that means I have 100 degrees minus 30 degrees, and therefore x is equal to 70 degrees. I can classify triangles according to their sides or their angles. When I classify triangles according to the sides, it works as follows. I have this first triangle. Over here, I can see that there are stripes on the sides. If there are stripes and there are equal many stripes on all of the sides, that means all of these sides are equal in length. So if this side was 5 centimeters, then this side would be 5 centimeters and this side would be 5 centimeters. If perhaps one of them had another stripe there, then that means only these two were equal in length and the other one was not. So if all three of the sides are equal in length, I call this an equilateral triangle. Now, my second triangle, I can see that the one side is not equal to the two other sides, but that two of my sides are equal. I call this an isosceles triangle. Two of these sides are equal in length. My third triangle, according to my sides, is my scalene triangle. And there I can see that my one side has one stripe, the other side has two stripes, and the last side has three stripes. That means none of these sides are equal in length. Now, let's first have a look at this equilateral triangle. I can see that all three of my sides are equal in length. And therefore, I can accept that all three of my angles will be 60 degrees. And that is a theorem. I know that if I have an equilateral triangle, meaning all of my sides are equal in length, no matter how big or how small my triangle is, my angles will all equal 60 degrees. So I know that angle A is equal to angle B, which is equal to angle C, which is 60 degrees. Once again, I need to give a reason for that. And my reason written on the right-hand side will be equilateral triangle. Now let's do an example using this theorem. Calculate with reasons the size of angle G. Now over here I have angle G and I see that they don't give me any information regarding angles or sides, except for the fact that I can see all three of my sides are equal in length. Now I know a theorem for that. I know if all three of my sides are equal in length, that means angle G is equal to angle F and is also equal to angle H, which is all 60 degrees. How do I know that? That is when I write my reason equilateral triangle. Next up, I have my isosceles triangle. And over here, I have two scenarios. So my first scenario is where they give you a triangle. And then they tell you that AB is equal to BC. So only your third side is not equal in length with the other sides. Now, if they tell you that AB is the same length as BC, then it automatically follows that angle A will be equal to angle C. I have a reason for that. And my reason is angles opposite equal sides. Because I know something about my angles opposite the equal sides that are given. Scenario 2 is where they give me a triangle and they don't tell me that AB is equal in length to BC. But they tell me that angle A is equal to angle C. Do you see that this is exactly the converse of the first scenario? So that means they give me that my two angles are equal in size. Therefore, it automatically follows that side AB is equal to BC. My reason for that is sides opposite equal angles, because I know something now about my sides opposite the equal angles. Let's do an example using scenario 1. Calculate with reasons the size of angle R. Now, I can see that angle Q has a value of x. Furthermore, I can see that QP is the same length as PR since they drew these lines for me. So, now I know that QP is equal to PR. That is given to me. And therefore, I can deduce that angle Q is equal to angle R, which are equal to x. How do I know that? Since my two sides are equal in length, it automatically follows that angle Q will be equal to angle R. And remember that my reason for that is angles opposite equal sides. Therefore, I can insert an x into angle R. Now, I want to calculate the value because they asked me the size of angle R. Now I know that all three of these angles added together has to give me 180 degrees. I have a theorem for that. So I can write x plus 50 degrees is equal to 180 degrees. How do I know it is equal to 180 degrees? I have a theorem saying interior angles of a triangle. So I can simply write interior angles of a triangle. Now I need to calculate x. X plus x is 2x, and 180 degrees minus 50 degrees equals 130 degrees. Now, 130 divided by 2 equals 65 degrees. Therefore, I know x is 65 degrees, but they asked me for the size of angle R, not x. Therefore, I must answer my question by saying angle R is equal to 65 degrees. Now let's do an example for scenario 2 of my isosceles triangle. Over here, I can see that they gave me my angles, and I see that angle Q is the same size as angle R. Furthermore, they gave me the length of QP, and they told me that it is 10 centimeters long. Now, they want me to calculate with reasons the side PR. I know that angle Q is equal to angle R, which is 50 degrees. How do I know that? That was given, so I can simply write given. Therefore, I can deduce that PQ is equal to PR, which is 10 centimeters. How do I know that? How do I know that my two sides are equal? I know that since my two angles are equal, it automatically follows that my two sides are equal in length. So my reason now is sides opposite equal angles. So do you see now that I am saying something about my sides because they gave me my equal angles? Therefore, I swapped my theorem around saying sides opposite equal angles, and not like in scenario 1 where we said angles opposite equal sides. Now, the last triangle classified according to sides are my scalene triangle. Now these stripes once again tell me which sides are equal in length. Now over here I can see that there's one stripe, two stripes, and three stripes. Therefore I know that none of these sides are equal in length. I also can see that none of these angles are equal in size. The same goes for the other two triangles. One stripe, two stripes, three stripes. So none of these sides are equal in length. And that is what classifies a scalene triangle. We know nothing about the angles or sides. Now, we have already classified triangles according to their sides. We can also classify triangles according to their angles. Looking at the first triangle over here, I can see that this is an equilateral triangle. If I have a triangle with all of the angles smaller than 90 degrees, then it immediately classifies as an acute triangle. An acute triangle is absolutely any triangle where all three of the angles are smaller than 90 degrees. That does not necessarily mean it has to be an equilateral triangle. It doesn't have to be. As long as it is any triangle where all three of the angles are smaller than 90 degrees. Then we have an obtuse triangle. That is where only one of the angles are larger than 90 degrees. The moment I have one angle larger than 90 degrees, I have an obtuse triangle. The last triangle is a right angle triangle, and that is where one of the angles is equal to 90 degrees. Here are a few exercises for you to do. Remember, the answers will follow.